Okay, I've been asked to do the Big Ten problems C, G, F, I, and J, so I'm going to do those for you right now and put those on remind. So down here on this one, it says the velocity of a particle from 0 to 9 is given by this graph above. Again, this is velocity. Now, which of the following values is the particle speeding up? So something we need to know, speeding up. In order to be speeding up, both your acceleration of t and your velocity of t have to have the same sign. So both positive or both negative. And if you ask me in class, I'll show you why. And then slowing down would mean they would have opposite signs. So A of t and V of t would have opposite signs. One would be positive and the other negative, or vice versa. So we want to find where V of t, V of t is greater than 0 and the acceleration is greater than 0 or both less than 0. So if you look at the line, this again is V of t. If you look at the x-axis, V of t is greater than 0 above the x-axis or positive, and V of t is less than 0 below the x-axis. Now acceleration equals the derivative of velocity, which means that acceleration is going to be the slope of velocity. So you look at this problem right here, the slope is positive, so the acceleration is positive from here up to that point. So here's where A of t is positive because the graph is increasing. And it's also positive from here going up to here. It's positive. So A of t is greater than 0 because the function's increasing. The function is decreasing from up here all the way down to this bottom point. So in here is where A of t is less than 0, decreasing. So I want to look at t at 3. So t at 3, V of t is greater than 0 because it's above x, and the green is decreasing. A of t is less than 0. So at 3, this object's slowing down. At t of 4, well, 4 says that velocity is 0. So since velocity is 0, that means the object stopped. So whenever velocity is 0, the object stopped. T of 5, so if I look at 5, which is right here, if you look right here, V of t is less than 0 because it's below, and the graph is decreasing at this point. So t equals 5 is our solution to C. Going on to F, it says a particle is moving along the x-axis. The position and velocity of the particle is recorded at various times on the table. Which time is the particle moving toward the origin? So these numbers right here on the top represent numbers, basically numbers on a number line. Okay, these are numbers on the number line, and then this is velocity. So something we need to know is if the velocity of an object is greater than 0, the object is moving right. And if V of t is equal to 0, just like it was at 4 on the last problem, the object is stopped. And if V of t is less than 0, the object is moving left. So we're starting at 3. So if this is 0, we're starting at 3 and the velocity is positive. That means the object's moving right, which is away from the origin. Here it says that the object is at the origin and it's moving to its velocity is 1, so it's at the origin moving right, so it is away from the origin. Here the object is at -1 and the velocity is negative, so it is moving left, so it is moving away from the origin. Here the object's out here at -4 and the velocity is positive, so it's right here and it's moving right because this is positive. So that would be the answer of the one that is moving toward the origin of 0. So the answer on this is t equals 6. And if we look at 5, it's out here at 5, and this says it's not moving at all. Okay, going on to G. G says the velocity of a particle is given at the graph from 0 to 11. How many times on the interval does the particle change direction? Well, if you remember, we said v of t means the object is stopped, right? So we know the object is stopped here, and it stopped there. So now this says change direction. So if you look right here, the velocity or the acceleration is positive because we're going up. So this means the object from stop moved right. So that's not a change. And it moved right till it gets up here. And when it gets here, its acceleration is nothing. So there's no slope there. So it stays constant. And then it comes down. Well, the object stopped here. Do you see the slope, the acceleration here? I'm sorry. The velocity greater than zero. The velocity greater than zero is when it's above. So that's where I should have started from the last thing. So this means the object's moving to the right the whole time. Because whenever the velocity is greater than zero, moving right. And then here it stops, but then the velocity is below zero. So now the object's moving left. And then here it stops again, but then it moves left again because the velocity is less than zero. It's below the x-axis. So the only place it changes direction is at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So wait a second here. Velocity of a particle is given. Change direction. Oh, it says how many times does it change direction? So it changes direction at t equals 6, but this one it's going left and continues to go left. Here it's going right the whole time. So it only changes direction once. Changes direction once at t equals 6. One time. The next problem we wanted was I. So the velocity of an object is in the graph above. What is the velocity? So we want to know what is the velocity of the object when the acceleration equals 0. So just like we said earlier, acceleration is the slope of velocity, and this means we want to know when is the slope of the tangent line of this function 0. So that's going to be right here at this peak place. There's a tangent line that goes like that. Nowhere else is there a 0. There could be a 0 here, but the problem is that's a sharp turn, so we don't know what the derivative is. So that means the acceleration equals 0. The acceleration equals 0 when t is 3. So this wants to know what's the velocity, so we need v of 3. So if I look up here, here's 3, and this is the velocity, so I need this y value. So v of 3 equals 4, so the answer to this one is 4. And then this last problem we got, the position of a bug moving along the x-axis is given by this position function, where a and b are both, I can't see what that word is. What's that word? Non-zero, is that what that says? I think it says non-zero. Find the acceleration. Okay, so what we need to know is that x of t, the derivative of x of t equals v of t. And then the second derivative of t equals the first full derivative of velocity, which equals acceleration. So we basically have to get the second derivative of this. So the first derivative, and we're doing it with respect to t, is going to be equal to a. Remember, a is an integer, a is a number. So when I do the derivative of any number, that is going to equal 0. So the answer for this is the acceleration is 0. Hope you guys have a good day and good luck on your test Tuesday and Wednesday.